Record. You going to verbalize problems tonight?
Yeah.
Okay. What kind of stuff we doing tonight? We still on conic sections?
No, we're on trig stuff now.
Okay, cool. So you got into the trig part of algebra 2 trig.
Yeah.
Okay, have you gotten to the unit circle yet?
No.
Okay, what kind of stuff are you doing? Why don't you give me some of your problems?
Okay, so we're just doing so for like this problem we have to identify each function value.
Okay,
And so it says SEC, so secant 0, given that cos 0 equals 2/3.
okay. Secant of 0
Yeah.
equals cosine of 2/3?
No, it says secant 0, comma, given that cosine. No, it's actually, yeah, it's given that cosine. Actually, I think that's a theta symbol.
Okay, I think I know what you're saying. You're saying this. If the cosine of an angle is equal to 2/3, what is the secant of that angle equal to?
Yeah,
Is that what you're saying?
yeah,
It's a very common trig problem where they give you one trig function and they want you to figure out all the others, or in this case, one of the others. So what do? Always draw a right triangle.
mm-hmm,
There's a lot of trig problems where that's always the first step. Not only draw the triangle, but label which angle is theta, because theta could be this lower right one, or it could be the top one. So I
mm-hmm.
have to label theta. Now you can actually dimension all three sides of that triangle. Based on cosine of theta being equal to 2/3, and SOHCAHTOA, give me two sides of that triangle. What's the opposite side? Or what's the adjacent side going to be?
Uh, like the bottom part.
Yeah. In other words, I can dimension that much because I know cosine is adjacent over hypotenuse.
Yeah.
Well, only way adjacent over hypotenuse, that's 2/3.
Mm-hmm.
Now, using the Pythagorean theorem, I can figure out the side opposite theta. What does it have to be?
Uh, three 3/2.
No, you got to use the Pythagorean theorem. In other words, x is equal to square root of the hypotenuse squared minus
Oh
the
yeah.
other short side squared.
Yeah.
So what's x going to be?
√5.
Okay. Now you have all three sides dimensioned. And
Mm-hmm.
I could ask you, what's the secant of theta? What is it?
Uh, two. I forget like the ratios.
Okay. Let's talk about the 6 most important trig identities. Let me list them over here. Sine, cosine, tangent. Now, each one of those has a reciprocal.
Yeah.
Tangent's easy, it's 1 over cotangent.
Mm-hmm.
The two that are hard to remember are sine and cosine. Well, here's the trick. The first letter is never the same. So it can't be cosecant, it's got to be secant. Which means sine has to be cosecant. Notice that it's a C and an S and a C. It's never a C and a C. or an S and a S. So that, and of course, the opposite is true. Cosecant equals 1 over sine, and so forth for the other two. So you have 6 reciprocal identities. Now, the nature of this problem was such where they gave you the cosine and only asked about the secant. I didn't really have to go through this process. You remember that the secant is the reciprocal of the cosine, then what is the secant here? Don't even need to look at that picture. It's the reciprocal of cosine. What does it have to be?
3 over 2.
Yeah. And I could have done that immediately. I didn't need to draw this triangle. On the other hand, if they want to know the tangent of theta, then I got to draw the triangle. What's the tangent of theta? You want to, let me give you some advice, Fed. You don't want to memorize these trig functions.
Okay.
You want to know them like you know your name.
Okay.
In other words, you want to more than memorize. You don't, when somebody says to you, what's the tangent of theta, you don't want to have to go through that thought process. Well, TOA, that's opposite over adjacent, which is square root of 5 over 2. Once you work with these enough, you know these trig functions like you know the back of your hand. Good. Okay. Which sine of theta is what?
Um, 2 over root 5.
Sine is opposite.
Yeah.
What's opposite to theta? What side?
Oh, root 5 over 3.
Okay. And which one are we missing here? I've got sine, tangent, cosecant. How about cosecant of theta? This one, you don't really have to look at the triangle. You have to know that cosecant is the reciprocal of what?
Of sine.
So just flip whatever the sine is.
3 root 5.
3 over root 5.
Yeah.
Now, most trig teachers these days do not insist that you rationalize these. In fact, it's actually a little better if you don't rationalize them. And they will accept this as an answer. Now, if I were to rationalize it, notice what I got to do. 3 root 5 all over 5. Well, that's fine if I'm talking about the cosecant. But now, what if I didn't know the sine and they said, well, tell me what the sine is. Now I got to flip that to be 5 over 3 root 5. And now I got to rationalize it all over again. You see all the extra steps that are required if a teacher wants you to rationalize it? Yeah. It makes it harder, not easier. And I honestly think that it's just a convention anyway. This convention we have of not having irrational numbers in the denominator. That's a phony thing. This is absolutely the same number as this. Yeah. They are not different. You put them into a calculator, it'll be the same out to 18,000 decimal points. Okay. So there really isn't anything wrong with this. And occasionally you'll have something that looks like this. Well, that's an irrational denominator that cannot be rationalized. I can't rationalize that. There's nothing I can multiply pi by to turn it into a rational number. Yeah. Square root of 2, I can multiply it by square root of 2. And that turns it rational. But like I said, in geometry or in trig, they start to change this whole philosophy that they've taught you about rationalizing irrational denominators.
Mm-hmm.
So your teacher is okay with that? Do you know?
She normally wants us to rationalize it, but I'm pretty comfortable with that.
Okay. Why don't you try not rationalizing it and see if he says anything? I mean, maybe you don't want to do that on the first time on a test, but you might go up to him and ask him, do you need these ratios? Because trig is all about ratios. It's not really about numbers. You take a trig function of an angle to get a ratio. Ratio of two of the sides of that triangle. All right. You got another one of these?
This one's a little bit different type of problem.
Okay.
So it says an equation of the terminal side of an angle theta in standard position is given with a restriction on x. Sketch the least positive angle theta and find the values of the 6 trigonometric functions of 0. So the function is 2x plus y equals 0, and x is less than or greater than to 0.
It's less than or greater or less than or equal?
Less than and equal.
Like that?
No, the other, or I mean x is greater than or equal to 0.
Okay. So, this is kind of the beginning of the unit circle. Circle has a radius of 1. This circle. That's why it's called the unit circle. And if you take this is actually your first introduction to polar coordinates, is the unit circle. Okay?
Okay.
Let me give you an example. If I draw a 30-degree angle, and it's the unit circle, this point right there is x comma y, correct?
Yep.
Well, if I take, this is y, and this is x, if I say to you, what is the cosine of 30 degrees? What is it? This is 1.
X over y.
No, it's x over 1.
Oh, yeah.
Adjacent over hypotenuse. Remember, the sine and the cosine are always over the hypotenuse.
Yeah.
Okay? So, cosine of 30 degrees is x. What's the sine of 30 degrees?
Y over 1.
Or y.
Yeah.
So what's happening is that no matter what the angle is, the x-coordinate on the unit circle is the cosine of that angle. The y-coordinate is the sine of that angle. Now, in this case, that would be, in other words, this point is not x comma y, it is the cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1/2. So that point right there on the circumference of that unit circle has those coordinates.
Yeah.
Now, that's the unit circle. And I can make my angle whatever I want. If I go 45 degrees, such that this thing is 45 degrees, then this point, cosine of 45 is root 2 over 2, rationalized. And the sine of 45 is root 2 over 2. So I can go around this whole unit circle and give you the x and y values of all of your common angles. By common angles, I mean those special angles from those two triangles. 30, 45, 60, 90, 120, 135. At some point, they're going to ask you to memorize all of those. What they're asking you to do is memorize 16 points on this circle. There's this one, there's that one for 45, there's that one for 60, and there's that one for 90. So there's 4 points in every quadrant. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, so far, you've really probably only dealt with trig functions of angles less than 90 degrees. True? False?
Yeah. Yeah.
They haven't asked you yet what's the sine of 120, right?
Yeah.
Yeah, by that you mean no, they haven't?
Yeah, they haven't.
Okay. So, question is what the heck does this mean? Reread the problem, because I'm a little confused.
Okay. An equation of the terminal side of an angle theta in standard position is given
Hold
with
on. Stop for just a moment. The equation of the terminal side of an angle
theta in standard position is given with a restriction on x. Sketch the least positive angle theta and find the values of the 6 trigonometric functions of theta.
Now, with angles, you can have positive and negative angles. Okay? A positive angle is one where you start from the x-axis and you go counterclockwise. Negative angle is where you go clockwise. If I draw a 30-degree angle there, that's negative 30 degrees. Okay?
Yeah.
Reread the problem one more time. I'm still trying to figure it out, what they're asking for.
An equation of the terminal side.
Okay, stop for a moment. They want the equation of the terminal side. There is no equation of the terminal side. What do they mean by the terminal side? In other words, if that's x, do they mean this side here, the terminal side? I don't know what that means. I really don't. I've been tutoring trig for 8 years. I've never ever heard that expression.
Okay.
Equation of the terminal side. Sounds like this is called the terminal point.
I think we just have to sketch it.
I don't even know what they're talking about is the problem.
To sketch the least positive angle theta.
Such that 2x plus y equals 0 is the equation of the terminal side? That doesn't make any sense to me. I'm sorry. If it did, I would certainly say something, but I have no idea what they're trying to talk about. Do you have any pictures, or is anything? Do you have anything on that you can show me visually, or are you pulling this all off your computer, right?
No, this is on my paper.
Can you take a quick picture of it and send it to me?
Yeah.
Because maybe I can tell by the following question on the previous question what they're getting at. You still have did you send me anything last time? Do you still have my email?
No, I didn't.
Let me write it. Let's get this out of the way anyway. Because once you do this, it'll be much easier to do it the second time.
Okay.
Just take a picture. Make sure it's vertically aligned, so that when I get it, it'll be straight up and down. Only because my computer is giving me difficulties. If it's rotated, it's not letting me rotate these pictures, these JPG files. Go ahead and take a picture. Do you know how to send it to that email address?
Yeah.
Okay, cool. Tell me when it says sent and only attach one picture. Are you using an iPhone or a Samsung?
An iPhone.
Attach it as a large image attachment
Okay.
or a large image file. You will be getting to the unit circle very soon. And I almost feel like I should give you my half-hour unit circle tutoring session. You're going to need it at some point in time, but we'll wait until you come up against it in class. Feels like this question is leading up to the unit circle, though. The terminal side. Did you send it yet?
Almost.
Okay. You don't need my email address up there anymore?
Just one moment.
Okay. Make sure you don't misspell it, because then it'll stay in that computer or that phone forever, and you'll never know which one is the correct spelling. I've had that happen before with students, where they'll spell it C-O-W-E-N, and then they'll correct it to A-N, but their phone keeps both of them. So the next time they go to email me, they don't know which one is spelled properly. Unless you are computer literate enough to know how to get rid of those defaults.
I sent it, and it's problem number 21.
Okay. Let's have a look at my email. There it is. Okay. Let's see if I can blow it up at all. Oh, good. See, that's what it does. I can't figure out why it does that, but that's okay. I can read it. Okay, all problems must be what on a separate piece of paper? What's it saying?
That was just for my homework.
Okay. So problem 21, an equation of the terminal side of an angle in standard position is given with a restriction on x. Sketch the least possible and find the values of the 6 trig functions of theta. Wow. This is a little bit new. Got to think about this for a second. Let me read the next set of exercises. Do you have problems in that also?
Yeah.
See, the next question is talking about the unit circle, because it said R is 1.
Oh.
I tell you what, rather than me wasting time trying to figure out what they mean on 21 to 30, let's go ahead and jump to the 30s and do some of those.
Okay.
And maybe by the next time I talk to you, I'll understand what the heck they're looking for in 21 to 30.
Okay.
I really haven't seen that.
Okay.
Let's just talk about the unit circle here. I can do you a lot of good tonight by talking about this unit circle.
Okay.
And it applies to problems 31 on.
Okay.
The two triangles, everything I draw on this page, you're going to want to memorize. Everything.
Okay.
Now this 45-degree one can be square root of 2, square root of 2, 2. A lot of school systems use that as their unit triangle. Okay? So, if I said, what's the cosine of 30 degrees? What's the answer?
X over 1.
No, read that triangle, the 30 degrees, and put the adjacent over the hypotenuse.
Yeah.
What's the adjacent to 30 degrees? There's always two lines that are adjacent to an angle. The one they're talking about is never the hypotenuse. When you see SOHCAHTOA, adjacent means the line that's adjacent to the angle that is not the hypotenuse. So there is only one side that is adjacent to 30 degrees. What is it?
Root 3.
Okay. Over the hypotenuse.
2.
That's the x-coordinate of this point. The y-coordinate is the sine of 30 degrees. Like that. Okay. Now, this is a unit circle, so that's always 1. And the very first problem they wanted you to solve, 31, is what is the cosine of 90 degrees? These are called quadrangles. Multiples of 90. In other words, 90 degrees is a quadrangle, 180 is a quadrangle, 270 is a quadrangle, 360 is a quadrangle, so forth and so on.
Okay.
Notice you cannot figure out the quadrangles from these two triangles. You can certainly figure out all 6 trig functions for 30 degrees, 60 degrees, and 45 degrees. But it's hard to figure out the quadrangles. Well, I'm going to give you a method for doing it. What are the x, y coordinates of that point I just put on there? Remember, every radius is 1 in this unit circle. So what is the first? What's the x-coordinate?
Root 3 over 2.
No, we're talking about this point now.
Oh.
Look at it. The x-coordinate is 1 unit, right?
Yeah, okay, yeah.
What's the y-coordinate?
0?
Yeah, isn't it? I'm on the x-axis, right? Okay. Now, I know that first number is the cosine of 0 degrees. The second number is the sine of 0 degrees. With me?
Yep.
Now let's go up and look at the 90-degree angle. That one right there. Tell me the two x and y coordinates of that point.
1.
Nope. It's the x-coordinate. Where are you at on the x-axis when you're on the y-intercept? Always. Look at my x-y coordinate and tell me what the x value of where I just pointed to is.
0.
Okay, what's the y value?
1.
Now let's do the same thing over here. Give me those two.
-1, 0.
And the same thing down here.
0, -1.
That tells you the sine and the cosine of all 4 quadrangles.
Okay.
In other words, I'm gonna quiz you. Give me the cosine of 180 degrees. Well, first of all, we'll answer the one in your book. I unfortunately can't turn back to the read them off to me. Starting with 31, it wants to know the cosine of 90 degrees. Well, what is that based on our diagram here? Remember, this is cosine. The first number is cosine. The second number is sine. So what's the cosine of 90 degrees? Read your xy coordinate.
0.
What's the sine of 90 degrees?
1.
Let's read 32 to me. Just read them off.
Sine 90.
Oh, that was the second one. Okay.
Tan
You're going to answer all of these. What's the next one?
Tan 180.
Tan of 180. Now, what do we know about tan? We know tan is sine over cosine.
Mm-hmm. So
what's the tangent of 180?
Undefined.
No. Remember the y value is the sine. 0 divided by minus 1.
Oh, 0.
Okay. You can have a numerator of 0. You just can't have a denominator of 0.
Yeah.
What's the next one they're asking about?
Cot 90.
What is it? Cotangent?
COT 90.
That's cotangent. Okay. Cotangent is cosine over sine. So what's cotangent of 90?
0.
What's the next one?
Secant 180 degrees.
Secant is the reciprocal of which, the way I tend to do trig, and it works well for me, is I pretty much consider these to be the primary trig functions, sine, cosine, and tangent. And cotangent, secant, and cosecant, I kind of treat as secondary trig functions. They're really not, to be honest with you. They're all equivalent in importance. But in terms of memorizing them, that's what I do. And I know that the secant is the reciprocal of what? It's either cosine or sine. What is it?
It's the reciprocal of cosine.
Okay. Tell me what the cosine of 180 is.
The cosine of 180 is
Just read it. That's why I drew these 4 quadrangle points. First point's always the cosine, second point's always the sine. So what's the cosine of 180?
0, 1.
It's one number. Notice that is pointing right there. Cosine of that angle is whatever the x value is. The sine of that angle is whatever the y value is. So what is the cosine of 180?
0.
Oh, it's that first one, not the second one. It's negative 1.
Oh, okay.
With me?
Yeah.
So if the cosine of 180 is negative 1, true statement, the secant is the reciprocal of the cosine. So what is the secant? What's the reciprocal of negative 1?
Negative 1.
What's the next one they want?
CSC 270 degrees.
That's pronounced cosecant.
Cosecant.
Notice that your trig functions, each one of them has a cofunction. what you do is you take the trig function and you stick CO in front of it. So that's how you go from sine to cosine. They're cofunctions. Tangent, cotangent. Those are cofunctions. Secant, I stick a co in front of it, it becomes cosecant. So they want the cosecant of which angle?
Of 270 degrees.
Okay. Well, the only thing we know at the moment is what the cosine and the sine are. Well, what's the reciprocal of cosecant? Here's the way you want to remember it. You always know that cotangent goes with tangent, right? So secant has to be the reciprocal of either the sine or the cosine.
So the sine?
No, never has the same first letter. So the reciprocal of sine is cosecant. Reciprocal of cosine is secant.
Okay.
So sine is the reciprocal of this cosecant. So the first thing let's do is figure out what the sine of 270 is. What's the sine of 270? Again, just look at your x and y coordinates. What is it?
1.
What's that number?
Oh, -1.
Okay. Therefore, what is the cosecant of 270? It's going to be the reciprocal of -1 again.
So -1.
Yeah. Okay, what else they got? And let me make some room by erasing some of this.
Sine -270.
Okay, hold on. Now negative is all we do is go clockwise instead of counterclockwise. So if I want the sine, excuse me, of -270, I'm going to start here. I'm going to go clockwise for 270 degrees, which takes me, it's the same as the sine of 90, right?
So it's 1.
You got it. You're catching on now. Keep going.
The next one is cosine of -90.
What's that going to be?
0.
Good. Keep going.
The next one is cotangent of 540.
Now, when you have angles that are greater than 360, what you want to do is subtract as many multiples of 360 away from that. Okay? If I take away 360 from that, I got 180. So the first thing I know is that the cotangent of 540 is the same as the cotangent of 180. In other words, always try to get your angle between -360 and +360.
Okay.
You can always do that. If I say the sine of 1200 degrees, take away 1080. You're left with the sine of 120. Okay? So those are called coterminal angles, where they're just multiples of 360.
Okay.
Okay? So now we need to figure out the cotangent of 180. Cotangent, what's the identity for it? Tangent is sine over cosine, so cotangent is what?
Cotangent would be...
It's the reciprocal of tangent.
So, adjacent over...
No. Don't think of it that way. You need some identities. Here's one identity. Tangent of x is always equal to the sine of x divided by the cosine of x. So I can give you the tangent of any of these quadrangles also because I'm looking at the sine and the cosine, or excuse me, I'm looking at the cosine and the sine. So it's easy enough to do this math. Well, the cotangent is just the reciprocal of that. Cosine x over sine x.
Okay.
Okay. So they want the cotangent of 180. Do the math. What's cosine over sine?
0.
Tell me what it is number-wise. Remember, it's cosine over sine. That first number is the cosine. That's the cosine. That's the sine. So tell me what cosine divided by sine is.
-1 divided by 0.
Which is?
Undefined.
There you go. A lot of these trig functions are undefined because notice that if the sine is equal to 0, then if you look at the reciprocal of that, you got to be dividing by 0. And anytime you divide by 0, you get undefined. So, what's the sine of 0?
The sine of 0. 0.
It's this one right here. Yes, 0 is the answer. In other words, this is the 0 angle, right? So the sine of 0 is 0. What's cosine of 0?
1.
Okay. So, if I say the sine of 0 degrees equals 0, then what must the cosecant of 0 degrees be? Remember, it's the reciprocal.
0.
Nope. The reciprocal of 0 is undefined.
Oh.
Right? In other words, if the sine of 0 is 0, this 0 is in the numerator.
Oh, okay.
So when I take the reciprocal of it, it's going to go to the denominator. And it doesn't matter what I have in the numerator. That's undefined. I can have 1, 2, 3, or 1,000,000.
Okay.
Undefined. So whenever one of your primary trig functions is equal to 0, its reciprocal is always undefined.
Okay.
Okay. Now, did we do all of the ones in the 30s?
Yeah.
Every one of them?
Mm-hmm.
Okay. That's not really leading you into the unit circle, but they should have. In other words, it's the unit circle that allowed us to answer all those things. Now, so you definitely want to memorize this. You don't need to necessarily memorize that. But you want to know all those quadrangles.
Yeah, okay.
And you get them by labeling your intercepts. Your two x-intercepts and your two y-intercepts. You know what those labels are, based on, not on trig, based on algebra or geometry. You know that if this is a unit circle, this point, x is equal to 1. And it lies on the x-axis, so y has to be 0.
Okay.
And you can always figure out these 4 points. And those 4 points are the answers to your quadrangles, which is nice because we have the answers to 30, 45, and 60 from those 2 triangles.
Yeah.
Now, there's something else. There's another way to memorize this. And I consider it superior because you got to memorize this graph anyway. This is the sine of x. That point is 360 degrees. Have you gotten into radians yet?
We've just learned converting back and forth.
Okay. Well, we'll stick with degrees for a while, unless they ask you a problem in radians. Eventually, you'll do nothing but radians. In fact, when you take calculus, calculus doesn't work on degrees. It only works if the angle is in radians.
Oh.
So that's why calculus is all about radians. And the relationship between degrees and radians is probably not what you think. If I told you something is 2 feet long, and then I said, well, how many meters is that? It's the same distance. It'll be a different number because meters are just a different way of measuring than feet.
Yeah.
Not the same with degrees and radians. They definitely have a conversion factor. In other words, 90 degrees, I'm always multiplying that by pi over 180 so that the degrees cancel. There's actually a radian right there. We don't write it, but it's there. So this converts to pi over 2.
Yep.
This is always the conversion factor going from degrees to radians. This is always the conversion factor going from radians to degrees. Just know that when you're converting it, you got to lose whatever you started with and pick up. In other words, if I'm converting degrees, I got to lose degrees. The only way I lose degrees is if that 180 is in the denominator.
Yep.
If I'm going pi over 2, which is a radian angle, I got to lose the radians. Well, there's the radians. I need the radians to be in the bottom. Now, what's that equal to? 90 degrees. Okay?
Okay.
Okay, but back to what I was starting with. If you memorize this graph, and like I said, you're going to have to at some point or another, then it actually gives you an easier way to figure out your quadrangle. Looking at that graph, what is the sine of 90 degrees?
1.
It's right there. Whoops, I had it on erase. Didn't mean that. It's right there, 1. What's the sine of 0 degrees?
0.
What's the sine of 270?
1.
Nope. Goes down to -1. It's this
Oh, yeah.
It's that point right there.
Yeah.
Okay? And this curve continues on. I only drew one period of the sine curve. It actually goes on forever in this direction, and it goes on forever in this direction, just repeating. But notice that if we use this method over on the left, we don't have to use this method of the unit circle. You're still going to have to learn the unit circle, but it'll be a slightly, they'll teach you this method to start with, I'm quite certain, because that's a good way to learn your quadrangles. And then they're going to expect you to learn all of these curves. I just drew the sine. Cosine looks like this. Again, that's 360. Again, that's 180. That's 270. And that's 90.
Okay.
And it always goes up to 1 and down to -1. Never beyond. In other words, if somebody tells you the sine of an angle is equal to 2, that's impossible. The range of the sine function is -1 to 1. That's it. There's no angle where the sine is greater than 1 or less than -1. Same thing with cosine.
Okay.
Not the same with tangent. The tangent curve looks entirely different. Tangent can go from -infinity to infinity, but not the sine and the cosine. And notice that if you memorize both of these, then you can always figure out your quadrangles. If you want to know what the sine of 60 degrees is, that's not a quadrangle. Go up here and look at that picture. That's why I want you to memorize those two triangles with their dimensions, because you now can complete a unit circle giving all 6 trig functions at all 16 points with the information you have laying on. In fact, I'm going to erase these because you don't really need to know these for the unit circle. When I say they're going to expect you to know the unit circle, what I mean is the following. They're going to give you a big old circle, and they're going to divide it up. They want to know that point. Then they're going to go 30 degrees. They want to know that point. And they're going to go 45 degrees. They want to know that point. And they're going to go 60 degrees. They want to know this point. And they're going to go 90 degrees. And then they're going to repeat in all 4 quadrants. In other words, the next one they're going to ask for is a 120 degree angle. Now, there's something that is very helpful, and that is figuring out this plus or minus sign on your trig functions. And there's a nice little acronym to figure that out. All students take calculus. What does that mean? That means in quadrant number 1, all 6 trig functions are always positive. In quadrant number 2, only the sine is positive. Cosine's negative, always. If I'm in a quadrant 2 angle, which is to say any angle from 90 to 180, cosine is negative, tangent is negative, but the sine is positive. And since its reciprocal always has the same plus or minus sign, then the cosecant is also positive. So I'll just add it there. It's not part of the acronym, but you just have to know that if a trig function is either plus or minus, then its reciprocal has the same plus or minus sign.
Yeah.
So let's leave them off. It makes it more confusing. So in the second quadrant, sine is positive. In the third quadrant, tangent is positive only. Fourth quadrant, only cosine. So now I'm going to give you some problems. Tell me what the sine, I haven't quite given you enough of the unit circle yet. And I do realize that we're right at about a half an hour here. Let me just finish one additional piece of information so that you can figure out this unit circle.
Okay.
And that piece of information is that when you are in the second quadrant, the way when you're in any quadrant other than the first, the way we're going to do it is we're going to figure out the equivalent angle. Well, if I say to you, what is the sine of 120 degrees? What I want you to do is figure out what the equivalent first quadrant angle is, and the formula that you always use is 180 degrees minus that angle. Minus theta. So, if I say, what is the sine of 120, what am I really saying? The sine of 120 is the same numerically as the sine of what?
180 minus 120?
60.
Yeah.
Now, what is the sine of 60? Looking at that triangle, an upper right.
1/2.
Nope. Opposite over hypotenuse.
√3/2.
Okay. Now, the last step is to attach a plus or minus sign to that. Is that going to be plus or minus?
Plus.
Because it's sine.
Mm-hmm.
Now, let me give you another one. Cosine of 150 degrees. Now, the way I tend to write these is I write them like this, and then in parentheses, I put what the equivalent first quadrant angle is. What's that one going to be?
30 degrees.
Okay. Now, what's the cosine of 30 based on that triangle? You'll memorize these whether you're trying to or not. It's just
Okay, yeah.
to work with them often enough that you're going to see these numbers all over the place. Square root of 3 over 2, 1/2, square root of 3, 1 over square root of 2, square root of 2 over 2. These are all the common answers to these common angles.
Okay.
So what's the cosine of 30?
Root 3 over 2.
What is its plus or minus sign being in the second quadrant? In other words, we're always looking at that to determine which quadrant we're in.
Negative.
30. So what is it? Negative. That's the way you do it. And you basically can do any angle. I'm going to give you one right here. Okay, you need a little bit more information. I haven't put it up here yet. I'm going to do it right now. I want to finish this before we go, even if we go over just a little bit, if you don't mind.
Yeah.
In the third quadrant, you take theta minus 180 to figure out the equivalent first quadrant angle. And in the fourth quadrant, you do 360 minus theta. So you need to remember everything you see on the right side there. You don't need this stuff. These are problems over here, so you don't need to memorize those. But you do need to memorize everything else you're looking at. This 180 minus theta, this theta minus 180, and this 360 minus theta. That's how you convert to the first quadrant angle. So back to tangent of 300. What goes in parentheses right there? And this is just my method. Your teacher probably doesn't use this method, but I love it.
Okay, 120.
No, what's 360 minus 300? We are in the fourth quadrant, notice.
Oh,
270 degrees. This is 180 degrees. This is 90 degrees.
Mm-hmm. So 60.
It's 60. So it's the tangent. The absolute value number is the tangent of 60. What's the tangent of 60? Opposite over adjacent.
Yeah, root 3 over 1.
Okay, you don't need the 1. Just root 3 is fine. Now tell me what the plus or minus sign is.
It would be negative.
Correct, because only cosine is positive in the fourth. Well, cosine and secant. And in the third, tangent and cotangent are both positive. So hopefully, at this point, you've realized that you can figure out the trig function of any angle as long as it is a multiple of 30, 45, or 60.
Yep.
If I said, what's the sine of 29 degrees, you can't do that, but nobody can do that. Everybody has to either look that up in a table or their calculator.
Okay.
Okay? But the whole first half of trig, you're going to be dealing with angles that are 30, 45, 60, 90, 120, 150, 180, 210, 225. All of those are multiples of those three common angles.
Okay.
Which means is all you have to do is take any angle, convert it to the first quadrant angle. That'll give you the ratio, the number, and then use this all students take calculus to put a plus or minus sign on it. And it's as simple as that. Okay? So you might even want to take a picture of this page. Even though it's not the neatest thing I've ever drawn in terms of the unit circle, I got a lot of garbage on there that But everything that's on there you need to know, including the fact that the x coordinate is the cosine of x and that the y coordinate is the sine of x.
Okay.
I guess I need that -1 right there. But everything else there is critical.
Okay.
These are most critical. That's what allows you to convert it to that first quadrant angle.
Okay.
Okay?
Okay.
So if you get this lesson, you've taken great strides. And in terms of those other problems that I didn't really know what to do with, if you can figure out how to do one of them, I can figure out how to do the rest of them.
Okay.
Because if you can get the teacher to tell you how to do one of them, I'll know what the heck he's talking about.
Okay, yeah.
And then I'll be able to do the math on all the rest of it. I'm not sure what these equations of the terminal side mean.
Okay.
How do you have an equation of a terminal side unless they're talking about the equation of the line that's vertical to the x-axis? I don't know. That might be what they're talking about. And that would have an equation, but it would be like x equals a number. So I don't know.
Okay.
The best way when you're trying to figure out how to do a problem and you don't know how to do it is try to find an example.
Okay.
You can go either on your online or you don't have a book, right?
No.
Maybe online there will be an example of one of these 8.
Okay.
Figure out how they're doing it, and with the rest of the knowledge that you've picked up tonight, you should be able to figure out how to do those also.
Okay.
Ved, I will let you go. You have a good rest of your evening. And
Thank you.
You're going to continue to just schedule on your own, right? You didn't want to lock up a time or night? Okay, that's fine. I will talk to you the next time.
Yep.
Bye-bye.